Yeah, good morning. As a managing director of Virtualisation, a very, very warm welcome to this not conference in this kind of discussion format. GRITLAB is the second year. We have a large project called Rail for Future. I think not only the project, but Rail for Future is the message. So rail would like to be the backbone of clima-neutral mobility in the next 10, 20 years. And to achieve this, we have to enhance the capacity, we have to enhance the quality. Last week we have a discussion round in Vienna, for example, discussing with Voestalpine, Siemens, ÖBB and the ministry the role of railway systems in the future. And one message was from all together, railway systems or going by rail must be more sexy again. So it must be much more attractive. And I think we should provide technology, ideas, innovation to achieve this way forward. And so I'm looking forward to discussions with the keynotes today. I'm very much looking forward, and also the master classes. So we have to keep going to improve railway technologies in the next years to come. And I'm looking forward for very good discussions today and have fun with this interesting format. Thank you.
Well, good morning, ladies and gentlemen. It's really an honor and a pleasure to be here with you today. This is actually the third day of a very, very fascinating and exciting week. I had the pleasure on Tuesday to be with Siemens, learning all about the twin activities on the bogies, and yesterday we had some deep sessions with GRITLAB and with virtual vehicle, and it was really fascinating to see how much we have progressed and all the knowledge here in Graz and around the world. So what to say on a keynote with so high expectation, with so many experts in the field. And I thought today I try something different than to the usual presentations I do. So I'm actually excited myself if it's going to work or if it's going to be a total failure. But sometimes we have to take risks. Digital twin simulation, virtualization, these are the big words, and I'm sure all of us, we are driven by these words and working with it with passion, driving that forward. And so do we at Deutsche Bahn. This is sort of our vision to have a virtual equivalent of Deutsche Bahn. That's sort of the end goal. On the end of the day, we want everything we have on the virtual side. Is it assets? Is it processes? Is it people? Is it weather? And so on and so on. So that our repair workshops, the traffic management, passenger management, freight management, performance analytics, all together as a twin with the aim to optimize our performance. That is what we are driven. This is something we are working towards for many years. This is what the team is working toward, and I've seen myself many presentations that explain all the benefits of a digital twin, of virtualization, and I'm pretty sure that most people in here already understand the benefits of having digital twin. So I'm not going to talk about that today. I think sometimes to look forward is also quite interesting to look back. And please join me on a little journey, and we go 30 years back. Once upon a time, there was a young commissioning engineer. I don't know if you recognize the sentence. There was a young commissioning engineer, and he got the task to commission a quite sophisticated locomotive, the Class 92. The Class 92 implies that the locomotive is launched in 1992. Some of you probably haven't been born at that time. But that locomotive is a multi-system locomotive able to drive from Scotland to Paris through the Channel Tunnel. It's dual system. It goes on DC current, on AC current. It actually has more than 4 different signaling systems on it. It's a complicated beast, and it doesn't work very well. It's had a lot of failures. Commissioning was really a nightmare. And at the time, it had computing capabilities, and we at the time actually launched our first remote diagnostic systems. And that locomotive, 1992, it was actually 1995 when it sort of started to work, was capable to transmit data over a modem, and we have collected that data and we made analysis. You might call it digital twin, you might not, but this is actually what we were doing, and we had already the vision at that time. What can we do with this power of knowledge? And we did that. This is actually, you can recognize it, these are the original slides I used at the time to convince management that this is a good idea. So this is sort of the database structure. We imported the data with geographical data, and we could exactly see where we had slip slide protection, where we had emergency brakes, and so on and so on. We had the architecture, how it goes with the maintenance and so on, and we had the vision of reducing total maintenance costs. The same thing as we are aiming today. The computer was slightly different at the time, but I can tell you, to walk around with that computer in 1992, that was really something. I felt really proud on the airport having that thing, and it was really cutting edge. So this is what we did, and it was working. It was working, and it was very beneficial. What has happened in these 20 years? I googled this. This is not my choice. This is sort of what the internet tells you officially. The biggest tech advances over the past years. We have smartphones, flash drives, Skype, video conferences is now a given. We take it natural. There's a lot of technology behind it, and so on and so on. I will not go through everything, but we have cracked the human genome. We have a vehicle on the Mars. Cars drive automatically, and so on and so on. Really, a lot has happened in those 20 years. If I sort of put this equivalent to the digital twin, what we had 20 years ago, and I actually, for this keynote, I did ask my team, okay, show me what we got today. That's what we got. It is, in principle, the same. I know it's a bit provocative, and I know a lot more has to be done, but I think we can, just for argument's sake, challenge ourselves. What have we really achieved in 20 years? Compared with all the other achievements, I think we have not progressed very well in 20 years, 20, 30 years. And this made me think, why? What is stopping us? I mean, they shoot rockets up, they land again, the cars drive automatically, it's huge technology, and we're still struggling to put the modem on a train, we're still struggling to get data. Whilst we have, in the meantime, fantastic knowledge on bogies, and what I've seen this week from those companies I mentioned before was very impressive, but it seems somehow encapsulated. And what I'm trying today with my modest little keynote is maybe to plant some thoughts in the people who make it happen. Because I truly believe in the meantime that technology on its own, which you do understand, will not make or break it with digital twin. We have to have a different approach. And maybe I can put some seeds here today that we actually work together in a different way. So, what is stopping progress? And again, a caveat, I know there has been more progress, but please allow me to be a little bit more sort of placative at this very moment, just to make the point, because there's some truth in it. I think one of the reasons we're not making progress is organizational gap. This is what I experienced in the 30 years. To each point, I will have a small deep dive later on. So bear with me at the moment, just to be with a type. Executive focus. Yeah? Some of these inventions before happened because a person really stood up for it and was going for it with full force. Do we have that in the rail industry? Then, one of my favorite topics is the holistic data approach, because digital twin needs data. Who is caring on the source of the data? I'd like to talk about that. And then is data availability. We are not very good of sharing data within the sector. Actually, I believe we're very, very bad. We try to keep everything ourselves, and that is stopping progress. That's what I'm convinced about. So, let's go a little bit in some details. Organizational gap, what I mean with that. Digital twin, again, the vision is very clear. I have an asset, I make a virtual duplication of that, we can all do the fantastic things. But what are the fantastic things? We have the engineer, we have the enlightened data scientist who knows exactly what to do, how to put things together, what we can do. We can predict a door failure. This door will fail at this time, at this point, with this component. This is great. But, and this is the actual talk I had with a maintenance person who tells me, I don't care. I don't need to know when that door fails. I don't have the time to attend this train. My schedule is full. This train will come in 2 weeks, and this is when I'm going to fix the door. So knowing that that door is broken or going to be broken doesn't do me anything. So we have to talk with each other what actually is needed, or how do we adapt the processes so that a prediction can actually do some benefit. I can only talk for my organization, and we have not achieved that yet. This simple alignment between technology capabilities and actual everyday need is very challenging. Challenging because of many reasons. There's a different focus on the people, there is different language, there is different understanding, there is a different perception what is important and what is not important. But we have a third element, which is the manager. What does it bring? What is the business case? How long does it take? We find it quite a challenge to prove a business case for a digital twin. To convince management, say, well look, if you invest this many millions, you get this many millions in return. And this is usually the language management is understanding. And especially some or most of the digital twin projects we do are very long term. They don't really fit into a year's or a 3 years budget plan. They take longer. As we're still working on the principles we have worked 30 years ago. So this is a challenge to put those three into a sync. There has to be a process where we holistically can approach the challenge of a digital twin. And we have to put the needs the desires, the capabilities of those three together. You can add, by the way, you can add government sector, and you can make this even more complicated. But in principle, you could sort of minimize it to those three. And I think we, as enlightened digital twin people, have to think about that. We have to manage it. It will not happen on its own. At least it did not happen the last 30 years where I was. Yeah. Or you will do better than I did. I'm convinced. So, this is important. And if one message, think about that. Think on the social, on the organizational implication. A digital twin is not a pure technical challenge. Actually, I would go in further saying it's not a technical challenge at all. It's pure a social challenge. And with that, I'm coming to executive focus. It really took me a lot of persuasion to put Elon Musk on, because I think, yeah, he is a figure who make things happen, and I think we need people like that. Yeah, the examples before, yeah, Amazon, Jeff Bezos, Apple, and so on. They all had figures on top who really going for it, who actually combined those three together. They had the vision, they had the money, they had the executive power, they had the technical knowledge to push forward. We need such people within the field who really put it forward and on a single point push that forward. And I mean, he announced his latest project, which is the robot. Again, in the press there was a lot of laughter about it, because that robot he presented on the launch was a human being in a lycra dress. But this guy, he did it in the past. He just did it. Yeah? Who would have thought that we can actually launch rockets into space in a private space company, and these rockets land again? Tesla and the truck, it sets new standards, and now he's even working, wiring the brain to the machine. Again, he's got the vision. The key here is the technology with very, very thin wires to connect brain to electricity. He's got the vision, he's going for it, and we need this kind of spirit to make it happen. So, with these words, I probably will trigger the next Elon Musk of virtual twins in this room, and I'm looking forward who will step up. Holistic data source, one of my favorite topics, and I had some very fantastic discussion with the colleagues from Virtual Vehicles and also for Siemens, and it was very refreshing that actually to find also people supporting that view. Nevertheless, I like to spend a few words on that here. A very important ingredient of digital twin is data, and I'm focusing here on diagnostic data. I know there is a lot more to the digital twin, but at the end of the day, we are relying on performance data. How is this asset behaving? What are the conditions, and so on and so on. And I'm many times amazed how people in the field of digital twin don't really understand the structure and the power of data we have on our trains already. This is a original data event we get from our trains. I think it's an ICE3, I'm not quite sure, but it doesn't matter. It's a code, shard code, as we say in Germany. I don't know the English expression of that failure code. And that failure code in a lookup table will tell us it's a door failure. It will give us time and the location maybe. And I've seen people very enthusiastically download these data. Oh, we can now analyze door failures. We can't. There is much more information on the train available. And I compare it to the iceberg. And this is the data underneath which is interesting. And although I know that all of you know that there is more data than that, is how are we approaching to adapt this data to our needs. Just a little refresher. A diagnostic data set, an event, DDS as I call it, has the event itself, it has environmental data, it has static dynamic data, and it could have lots of additional data. So if I try to represent that here, this is what we get, this is really what we need, and this is what we have to cultivate. And this is really the message here. This is, I myself have developed diagnostic data set as a commissioning engineer, as a development engineer, not as a maintenance engineer. And this is how 80% of the diagnostic data on a rail asset is actually designed. It's not designed for maintenance. And here we have to work. Just some examples what I mean with environmental data. I have here, this is the failure code. It's actually an HVAC or the door. It gives me some information. It gives me environmental data. It gives me counter data, and it gives me some dynamic data. Actually, diagnostic capability on our assets enable us to tell on this event the current was that much, the temperature was that much, the train was in braking, and so on and so on. So, like a doctor, I get lots of information which actually enables me a totally different approach to analyze the performance of this train. But who is defining in this event what actually we need here? And this is what we have to be better as an industry. Here I tell you an example how that looks like. This is an actual example the team of Cord is working on. It's the door modeling of the 429 outfit. You see, this is a train. It's actually a flirt train. It has some doors, and this train hasn't got many doors. So a door failure has some significant impact. We are working on a twin structure with this, and this is the actual model of the door. So getting this information, if you the functionality of the door, if you're modeling, this is how it looks like. This is the information we do not have at Deutsche Bahn. This information we rely on a sub-supplier who's providing the data, who has the trust to develop that system together with us. And this is one of the important conditions that we're working together on this level. Having the knowledge how the door really works, we can actually analyze some very specific items in this model. So this is the motor current of a closing door, how it behaves. Out of the analysis of these patterns here, we could actually predict individual parts of this door. It's not just a door failure. I can actually tell this drive unit will have that and that problem if I have that knowledge, which I can multiply with this and into that. And we've kind of done that and have actually found out that this is the diagnostic data we get from the train, the green fields, so each line is a diagnostic set, green we get, red is missing. And this is a process we have to get into together with the sub-suppliers. How can we optimize that? I know there are different school of thoughts that, yeah, let's stream all the data from the train and then we make some magic and some machine learning. I actually truly don't believe that. I believe we have to work together to make sure that on the train, on edge, we have the right information which helps us to build digital twins which are powerful, which really deliver some message. And this is not going to happen in a one-time circle. This is a continuous improvement. The more we learn, the more we have to adapt. So this implies we have to adapt the capability of analysis on the train on a constant basis. At the moment, we're not equipped like that in industry. Just to get another safety case or homologation for another diagnostic software part is very difficult. Neither have we got the process of exchanging with the industry to do that, nor have we have the knowledge gap, which I said before, between the maintenance staff, what is actually required, the development engineer and the operator. Again, this is a technical challenge, but it's also an organizational and a legal challenge. And we can achieve this only in partnership. I'm coming to the last point, and this is the data availability. So one thing is to get the right data and make sure that we have the data to analyze and import it into a twin and make our conclusion and optimization with it. And we had a lot of discussion in the past. For those who may be not familiar with our approach is to build partnerships. We're making partnerships with OEMs, with Siemens, with Bombardier, with Stadler, but also with door suppliers, with air conditioning suppliers. And there's some interesting debate. Again, it's not just technical issues, there are IPR issues and so on and so on. For instance, we have a case where a sub-supplier said, well, Deutsche Bahn, we're quite happy to share with you our deepest knowledge, as long as we have NDAs and so on and so on, but you have to guarantee us that nobody else is getting the data, especially the OEM. So the sub-supplier to a OEM is actually afraid that the OEM gets too much knowledge from the subsystem. And that itself is actually posing the challenge, and one of the reasons why we're not getting together. We're not sharing data. Everybody's shielding it off. And in the same term, everybody is actually providing a system to get data. I get at least once a week, somebody is offering me a IoT system, and of course, their system will also deal with all other data. But it's their system. And then I go saying, well, look, I'm sure it's very good, but your system doesn't help me because Siemens will never ever import data to your system, and I can understand why. This is just I don't say Siemens said that, it's just to put more graphic. So the challenge is actually that we can get data off the train into a secure space. In a secure space where the data is available in a controlled and defined manner, and it can be shared to a way it doesn't hurt the sub-supplier. It's legitimate to say, well, look, this is my IPR, I can't distribute it. On the other hand, we actually need some data to perform that asset. And also the sub-supplier needs some data from others. For instance, what are the operational conditions to make the same benefit? So we actually drawn this kind of graphical representation that we need kind of a framework, a place where data is going into, and then that data can be accessed in a holistic way. That is really the challenge. And there are some initiatives about that, and one of we take very serious at the moment, I'd like to share with you at this very moment. I invited my friend Olaf to have also a few words. I have not translated that one from German to English, I do apologize for that, but on the website is everything in English and German, and this state German, so I thought, well, okay, I will not be so vain and translate for the Chancellor. But basically, The initiative where the German government is very keen on is called Mobility Data Space. It's not only a German initiative, but it has originated and is also compatible to the Gaia initiative. But basically it is what it says, to create a data space for mobility. So not just a data space for everything, so actually the government has recognized we need a safe space for mobility. Everything to do with mobility. And this is what they have been set out, and we're actually quite happy about that, and we evaluating very strong at the moment how to make this a success, considering all the things I am trying to explain before. This is some of the slides. I'm not going into details. It's actually quite easy. Picture the cube we had before. It is a physical and legal framework where you can put in data, and that data can be shared. And this is what the government is doing now. It is not just a thought. You actually see lots of companies pushing for it. And at this very moment, it is heavily dominated by automotive. And we have to ask ourselves, should we also be here present and make sure that not just the car manufacturers will have the benefit. But on the end of the day, I think thinking holistically, we need to think about mobility, not just rail. Because mobility has to be in a mode where you have a seamless travel from A to B. And I think in a form there also will be some kind of cars involved in that. So it makes absolutely sense to look at mobility in a holistic point. And I don't really stay here and say we have to join and so on. I would invite you to have a serious look how we can participate on that. At least we at Deutsche Bahn, we're going to do it. We see this as a unique opportunity. So, you may be soon relieved from the keynote. Let me close with the key takeaways I'm trying to put over here. First of all, we need to speed up. I think we cannot be happy with the progress of 30 years. And we have to ask ourselves some serious question: how can we speed up? So this commissioning engineer 30 years ago, if he is going into his pension, he might be satisfied or still feel unsatisfied. Digital twin has to be fit for purpose. We can't do digital twin for the sake. We really have to think, where does it fit in, how can it adapt, but also how can we adapt the processes around the digital twin. I'm not saying digital twin has to adapt to the maintenance, it's also the other way around. We have to adapt the maintenance to the digital twin. And therefore we need to rethink how we optimize the assets. It's not just the data on the side. A pure working digital twin will also affect how we build new technical systems, and that dialogue has to happen. Operators, OEMs, system suppliers, and so on, government, we have to work together closer. We have to go in genuine partnerships. We have to share experience data. This is not going to work on its own. No single company will provide a data platform, will provide a system. It has to be something where we work together. Sharing data is actually one of the few sharings where it multiplies. If I share money goes away. If I share data, I'm getting more in return. So please remember that. And I think also talking about the management, we have to focus on lighthouse projects, as we call them, that sticks out to motivate and really take the key stakeholders with us in order to generate more interest and more money to achieve our goal. With that, I'd like to thank you very much for your patient listening, and I'm looking forward to this interesting day today. Thank you.
If you like this video, please comment, share and subscribe to my channel. Thank you very much.